Hello all, and we will be doing our heart disease analysis in R, and this is the complete tutorial for that, the second part. And I sincerely apologize for uploading this video a little late. So I hope you've seen the first part, and if not, please go ahead and see that. Now, I have done a little improvisation in this, and that is like I've resized the plot. Okay, so this is the GitHub link wherein you can find this under the name of when you go in the repository, you will find complete heart disease analysis. There you click and you will find the entire code over there. I'll also provide the link. And I will not go through the entire thing because the goals, objectives, and how we have done the visualization and manipulation of data is being clear in the first video. So the only thing which has been added here is that the resizing of the plots. Okay, so you can use this REPR library and then you can just resize the plot width and length. Okay, so coming to the part 2 of this video, and we will first start with this is the model building part, and we will be using SVM algorithm, and we will make prediction using logistic regression and also using the random forest. Okay, and so this is, first of all, we'll check the null values, and this is how we'll do it. I'll just increase the size so that things will become more clear. All right, so one way to just check null values in R is that you created the sum is.na, and data2 is the data which we are working with, where an entire data frame is being stored. And when I check it, it is 0. And when you see, this is another way, whereas simply you will write the function is.null, which will tell you in Boolean expression whether you've got null values in a data or not. So we don't have any data null values, which is good. So we can go ahead in training and testing of the data. So for training, for machine learning projects, R uses caret library. Okay, so we have imported this library and I have set the seed as 10. This is done so that for every, model building, for every code, it will just take only that setted seeds. Okay, it will not reshuffle it, so that there will be consistency in the results. So to give you a brief about the data, we have got some 303 rows and 13 columns, and this is the column names. As you can see, target, sex, fps, cp, resting sugar, what is the slope, ca, thal, and age, and all these things, cholesterol and so on, so okay, so now what we go in, we will now partition the data. So I have not written here. So what we will do is we will split the data set into 70 and 30 ratio. So 70 would be the data, our training data, and 30 would be the testing data. So split the data set, and what we will do is I'll create an object in trained row, and in that you will use this keyword create data partition. And what you will create here, I will use my data to which column, target. So this usually we will use the target variable here, whatever is your target, depending on the column name you have. And partition, you will provide 0.7 and list is false. And then in train data I will provide in train rows, and in test data I will provide only the target, that means minus in train rows. Okay, all right, so that means train data will contain 70% and the rest will go in the test data. All right, and then this is just expression which will help you understand how the data has been partitioned. Actually, this is just a check and percentage formula, simple, that final minus initial upon initial into 100. So this is like n rows training data divided by n rows plus, that means 70 upon 100, that gives you 70%. Okay, so this is how the data partition is being taken place. If I'm going so fast, that means this was just a quick check for us because we just wanted to check the percentage, right? Whether it has been segregated into 70 to 30%. All right. Now what you do is you create two lists so that we can store our results in those two lists of various algorithms that we will be using now. The first we will use list is AUC, which will be the ROC curve score, and another one will be the accuracy. Okay. And I'll create two lists, and then we will go on to fitting the model into logistic regression. So now as you can see, okay, I will also show you a little more things here that will be, I would say, errors also, so that if you are a beginner, things would be more clear. So this is, again, I have set it as CS 10, and then in an object called Logistic Regression Model, you place this train, and then here you give the target. Now these are the parameters which have been passed with Logistic Regression, and you can always see this with Shift and Tab hit simultaneously, and you will get everything here in the printed form. This is your train data, and then you can go ahead, scroll down, and see all the parameters that you can pass with this. So these are the train data which you can pass here, like x, y, method, preprocess, family, and so on and so forth. TR control, which we will see, and this is the another thing which you can pass, form data, weight, subset. So these are the parameters that you can pass with this. Okay. If you wonder how and where I'm getting these parameters, you get this by hitting Shift plus Tab simultaneously on your keyboard, and you will get all these things with the description. Okay, we will see this in detail further. So now what happens is that now I get a big error here because it is asking me when I run this, it is asking me for a package E1071 not found. That means it is required. So what you have to do is you have to simply go and install this packages, and dependencies is true. That means all the dependencies related to this package will be downloaded and it will be imported here, installed. So again, you will run this. What happens, you will find again an error. Okay, why? Because I am using this library PROC to plot the ROC curves, but this library is not there. So I will again import this package. So what happens is that you before using anything in R, you have to install the packages here first. So make sure that it has been installed, because when I was running it was not installed. I actually rebooted my system. uh, I shifted one from one place to another place, so there was a lot of problem in that to figure things out. Okay, so this was, I installed all these dependency. Previously it was there, but then again it just got installed. So now I have these two packages, that is E107T1 and this one, ROC, right? So now I will explain you the code, which is the final run. This is the same code, and then now let us understand what does this mean. So I just told you how do you get that. Simply hit Shift Enter, Shift and Tab, and you will find all the parameters to pass. So I am using here target because this is the output or the variable that you give here. This is the tilde operation or function here that I'm using. And then I use the give the data, train data, that is I'm passing in the training data, and method is GLM. What is GLM? GLM function is nothing but this is generalized linear model. Okay, and it is different from journal linear model because here it allows the response variable, that is the target, and this can follow any different distribution apart from normal distribution. Okay, so this is generalized linear model is basically used to fit your linear regression models, and which follow normal distribution. So the family is binomial, it belongs to this. And now I will make predictions. Again, I'll create an object, and that I will predict what this model, the training model, and I will test my data on this. Okay, and then again I will make a probability object, wherein I will predict this logistic regression model, test data, and type probability. Okay, I will provide the type is probability because I want to find out the probability of it. And then I will also print the confusion matrix of, again, I'll give the command confusion matrix, and therein I will give this logistic regression prediction and the test data, the target. What is the confusion matrix? Right, which will give me the entire report of right and wrong predictions. Then this is the code for two-line code for printing the ROC curve. This is again accuracy and accuracy to get these statistics, or I will say the numbers for accuracy and AUC. So this is what I'm getting it as numeric, and I want the test data of what the target column, and as numeric give it in matrix logistic regression probability. This is the object that we have used here, and then I've used accuracy. Okay, And then you've got, okay, let me just reduce the size of it so that you can understand. And then you go to again create another object for accuracy for logistic regression, and then you can just go for accuracy. Okay, this will print the accuracy and this will give you the AUC score of it. Now this was about the logistic regression. Okay, and now let's come to SVM. I have just changed the parameters here, rest things remain the same. Okay, so just copy the code and you can just simply write here. So in the SVM model, create, again take the seed as 10 so that the results will be more predictable and will not reshuffle. Then train, okay, and then target, that is the your output variable. Data is train data that we have created here, if you can see. Where is my data? Here, train data, okay, and test data. These are the data which we are playing with, train data and test data. And again in the SVM, I will put the train data, and method is SVM radial. TR control. Now let us understand what is all this. I hit shift and tab and this is what I get. You can see the entire data. Now let me just go to what we have used here. Method is SVM radial. What does method says? What is a method? So this is a string specifying which classification or regression model to use. Okay, so I am using what model to use. I'm using SVM, and what method I am using it as radial. Okay, now the pre-process could be anything. It could be center, scale, range, PCA, median impute, KNN, spatial sign, pre-process, or train control. Okay, so this works, this train control and pre-process will effectively when you're using other parameters also. So for this, for pre-process, I'm simply using center and scale. Okay, for SVM radial. So let me show you it in big form and take you down to pre-process. Okay, so the pre-process, as you can see here, it is center and scale, and with different, if suppose you're using PCA, you can use PCA. If you're using KNN, you can use KNN, right? Okay, so the metric is ROC. Of course, you can use different metrics like accuracy. You can use R square, or you can use root mean square error, any one which you prefer. And the thing now, this is TR control, which I will just let you know in a short while. What is this? And fit control. Okay, and this is the object which we have created. What does this TR control do? Now this TR control is control the entire function. It will define how does this actually has to work. Okay, and this tune length, I've not used this tune grid. I've used tune length. So tune length is nothing but just defining how many just like for tuning your hyperparameters, it says that it is for granularity, provides granularity in tuning parameter grid. Okay, so I will let you know in layman language what does this mean in a short while. Okay, and the rest thing is then prediction, probability, confusion matrix. These three objects are same as the logistic regression one, and then we have printed these scores, AUC and accuracy. Okay, now I want to tell you that you will get an error when you will run this code because it needs an kernel lab. Okay, and when you will search about this okay, when you will search about this kernel lab, or it will tell you what does this mean. This is kernel based machine learning methods for classification, regression, clustering, and it is best used when you're using support vector machines, spectral clustering, kernel PCA, Gaussian processes, QR solver. Okay, so when you're using these algorithms, you need to have this kernel lab installed in your Jupyter notebooks or in your any PyCharm or something which you're working with. So now what happens is, or RStudio, sorry, not PyCharm. Okay, so where was I? Yeah, so we will just install this package as kernel lab, and when after successfully installing it, now comes the part. I was talking about fit control. What was this fit control? So let's just define this fit control. In this fit control, what I do is I just give fold. We have learned previously what is this k-fold means. Okay, and there's a video dedicated to explaining what is k-fold CV, which you can see in the description box. I provided the link. So what happens here is that I'm dividing my training data set randomly into 10 parts, and then I use these 10 parts as testing data set, and I reserve one part, you know, okay, let me read it out. How should I explain this? So what happens here is that I divide my training data set randomly into 10 parts, and then using each of the 10 parts as testing data set for the model trained on other 9. Okay, so I reserve one and I test, and that becomes my testing part, and the rest 10 becomes my training part. So rigorously I do it 10 times so that it is been trained, it has been controlled in such a manner so that it goes on repeatedly learning in such a manner so that nothing is missed out, and it learns from these samples well. This is what I'm doing. I'm reserving one part, and then again it is training, and then it is reshuffling. Then again the second part becomes the testing, the other parts become the training models, and so on. Okay, so there's a dedicated video. Please go ahead and see that. It will aid in proper learning of it. So I will repeat it 10 times. Okay, so we'll perform an average of 10 error terms obtained by performing 10 fold CV 10 times. You can, play with around like 5. You can repeat 5 times. You can give 10 fold is like standard, so that's why we give 10. Otherwise, there's a lot of I would say pressure on resources. When you start consuming more resources, you give more repeated numbers and so on. So let it be more. Um, and the data set is not too big. It is having just 303 rows. So this is good. It will give you a good result. And the class probability is true. Let's move on further to different parameters, which will evaluate the performance using the following function, that is the summary function, which will be 2-class summary. Okay. So another thing now, SVN model final run, when we run it after all setting up all the errors, you will get this thing, setting levels and setting directions. That means it is run successfully. And then last one is random forest again. It is just same, but the parameter changes, and that becomes to importance and entry. Again, you can see all the parameters by hitting shift plus tab simultaneously, and you can see all the information right here. So what all you can pass, local n parameters, you can number of times, proximity, norm dot votes, and so on. Okay, so this is a study in itself. What random forest completely. It's so interesting. Okay, then again I print the AUC and accuracy and confusion metrics and so on. And now the time comes for comparison of the AUC and accuracy between various models, and this is the result part. So what I do is in the row.names an object, I will name the accuracy. In column names, you give accuracy in AUC. Then you combine, cbind it, column bind, and as.data.frame. So I'm just combining it, making it more presentable in the form of a data frame, wherein I give it a matrix, AUC and accuracy, and I give it a like 3 rows and 2 columns. That's what I provide, and dimension name is list row dot names, and here n dot columns. Okay, so this is just a normal setting of the data frame wherein I provided the names and of the rows and columns, and also now this is just filled in the details. Now you can see the summary as logistic regression give me the accuracy of 86.6%. that means roughly 87%, which is higher than SVM and random forest. Okay, you can also use the stochastic gradient descent, hyperparameter tuning, and various other algorithms, KNN and stuff like that. And you can see which algorithm further gives you better accuracy and AUC. And this AUC is 92 for logistic regression, which surpasses SVM and random forest. So our choice and for this model could be a preferable choice, better choice is logistic regression compared to other algorithms. Now, if you want a summary of this logistic regression, simply write summary and coefficient, and you will find all the important statistical information of that. Now, now you get the standard error. This simply means that how far or distributed your data set is. So I can simply make out the less this is, the more normal distributed your data is, less spread the data. Z value, again you've got the Z value, and this is how you derive Z value. Value minus mean divided by standard deviation. And what does this Z score tell you actually in statistics? Its significance is that it tells how far a value is from the average of the data in terms of standard deviations. Okay, that means I can simply understand that there are outliers in my data. And when we were doing visualization, we understood that there were, yes, many outliers. And you can see that the THEL2 has a higher value, 1.03. And here also, THELACH has 1.32. Okay. And please don't ask me the entire full form of these. This is something very tricky. Okay. So, I mean, the lower the value, the better it is, because it is close to the normal distribution. It is not an exception or an outlier. So the standard score, or you can say it as a Z score, it is useful because it allows you to calculate the probability occurring within normal distribution, and it also enables you to compare two scores from different normal distributions. So it has its own utility, the Z score. If you want more statistical detail, then you can definitely search out how it is impacting your data and what are these values referring to. Okay, the standard error and the estimate. Now if you can see here, the males and, where is it, standard error, I wanted to show you something. Anyways, it will come down. Okay, so now let's just print the confusion matrix for all the algorithms, that is logistic regression. And this is what it comes, and you can find here that our logistic regression predicted 34 and 44 cases as right. That means if they were not having any heart disease, so it was predicted rightly. And if they were having, it was also 44 cases were predicted rightly that they were having heart disease. And you can see 5 cases were classified as yes, but they were not having any heart disease. And there were 7 cases which were having heart disease but were classified as no. So these were the errors that our algorithm made. Okay, so that's why its accuracy is 86.6%, 87%, and you can see the confidence interval is 95%. Okay, and the p-value, so p-value is generally used for hypothesis testing. And if it is, like it said, that if it is less than equal to 0.5, then you can reject it and accept the alternative hypothesis. So if you have set any hypothesis for your project initially, that you want to prove something, and that is your initial hypothesis, then it could be rejected or accepted based on the p-value. Then these are other statistical measures which would help you to interpret the results of sensitivity, specificity, and so on. Okay, I'm not going into much detail because of the sake of the length of the video, but if you want more statistical details in length, do let me know. Okay, in the comment section. So, okay, so this has been said. And confusion matrix for, again, random forest can be checked here. So it is making more errors, 10 errors and 5 errors here, as you can see. And for SVM, again, it is classifying 10 objects wrongly and again 7 objects wrongly. Okay, so you can see its value. Now the final concluding is that we compare the area and ROC accuracy of the model prediction shows that the logistic regression performed best given the 3 algorithms or 3 models that we have tested. For random forest, SVM, and logistic regression is the best one for that, and others are giving low accuracy as compared to that. And then further fine tuning could be done with logistic regression, and you can also use different parameters and experiment with different parameters values so as to find out whether your model becomes gives you more accuracy or not. And this is not the final thing, guys. You can always experiment. It is just reference for you, so you can keep on experimenting with various things, with various methods, with various family, and you can use, try changing all these things a little bit here and there, modifications, and you can um, go ahead with more better results. So I think this was for this video, and go ahead and see this. I will provide the link, the necessary links which would help you to better understand this model in R. Thanks for watching. Again, apologies. Thank you so much.